Hi guys, today let's talk about the Internet of Things. As you know, Internet of Things is becoming very popular and a lot of people are beginning to put interest into knowing what Internet of Things is. Even people who do not want to study Internet of Things want to know about it because it is existing in society and you can't really play without it. So it is quite important to have a good knowledge of what Internet of Things is, even if you do not want to study it as a course. Today we'll be just looking at the introduction and we'll be talking more about the Internet of Things. I will urge you to find time and go through what we are going to say. We are not promising to be completely detailed in the world of Internet of Things, but we want to look at some sections that we're very interested and are also key sections that anyone who wants to know what Internet of Things needs to study. Let's continue. This is a brief outline of what we're going to talk. We'll talk about how the Internet of Things come into play. We'll also look at the concept, what has its influence, the application, the key technology behind the Internet of Things, because the factual standard, the challenges Internet of Things is facing. We'll talk about big data, cloud computing, and how it is related to Internet of Things. How, how did Internet of Things come into existence? Before now, you know that computer systems are using the dogs or the command line to process data, and most of the data processed are just computing related data. So, but after 1995, when Windows came into existence, everything changed. And it was at that time that Bill Gates proposed a paper he called the Road Ahead. So Bill Gates was looking at if the processing power of computer increases, if the interconnectivity of computer increases, then it would become possible for a lot of things to communicate with the computer. So he was just proposing that these are things that might happen in the future. Another great boom to the Internet of Things was the paper proposed or that the paper from the ITU in 2005. So the 2005 report from the ITU gave a framework of what the Internet of Things looks like. It talked about how the Internet of Things will be, looking at that there should be a section that should be able to sense what is happening in the environment, and also there'll be a section that can transmit these information sense to another device in a different location. So they looked at holistically the Internet of Things and what Internet of Things is all about. Then after that, in 2018, IBM came up with a good plan and proposed what they called the smarter planet. So IBM was looking at proposing a planet that is a bit smarter than what we see today, and they called it Smarter Planet. So their thought was that they will have a planet different from our planet, and that planet, or let me say a city, but it's called planet. A city that is very smart, a city that is capable of doing a lot of things on its own without full human interface to that operation or the things that the city will be able to do. But right now, as we speak, if we have not heard, then we have seen. If we've not seen, then we have heard. A lot of smart devices, including smart home and also smart watch and a lot of other smart devices. And we also know that the Internet of Things is now becoming a channel for human and machine interaction. So in the next slide, we're going to look at other things regarding the Internet of Things. So still on the history or the background of the Internet of Things. Now let's look at let's look at them in these three phases. The three phases of wave. The first wave was in within 1980s. So within 1980s, the smart guys then came up with what they call PC, which could be translated as personal computers. So we all know that before then, you hardly see personal computers, or there was no existence of personal computers. What they had then was big computers, mainframes that were used for processing computational problems. But from 1980s, a lot of other companies started producing personal computers, and those personal computers came with user graphics interface, so making it possible for people who are not computer guru or mathematicians to make use of the computer. It was becoming easier for them to use the computer. At that point, the processing power of the computer was not that much, so the information processing was a big problem to the Internet of Things, to the existence of the Internet of Things. So the second wave came and tried to solve that problem, increasing the processing speed of computer and also increasing the intercommunication of the computer systems. And the milestone was the launching of the internet. So internet became available for people to use for communication. And the internet being available for people to use for communication, the problem now becomes how will information be transferred from one place to another place. If the information is on the data is big, or is the possibility of transferring the data from one place to another place? So that was the major problem after the second wave. Then the third wave came to solve that information transmission problem. So the third wave within 2010 and now came up with a lot of things like the big data, the cloud computing, and the Internet of Things. So the cloud computing and the big data are like major breakthrough in this information processing and information transmission. And but that also came up, turned out to have its own problem, which is the information explosion. So information explosion means that now, because you have computers, you have PCs everywhere, because you have internet everywhere, a lot of information, a lot of people begin to have access to the computer, a lot of people begin to send information on the internet, then information become or data became very available everywhere. So you now begin to have information explosion. Now let's look at the device to support the practical aspect of this course. So we are looking at using the ESP8266 module. This ESP8266 module is capable of having interconnection via Wi-Fi. So it is a good device to practice Internet of Things. If you have one, you can use it. If you don't have one, it is very low cost device. It's within around £5 or less. you can acquire one for your own use. Still talking about the development support of the Internet of Things, we can see the increase of the increase in the Internet of Things. The blue part talks about represent the Internet of Things. So from 2012 or thereabout, there was a very rapid increase in the use of Internet of Things. So even when you compare it with the use of internet, you see that the Internet of Things became more used than that of internet. So this is talking about the increased number of machine and human through the internet. We also see that the internet connectivity speed also increased. It started increasing to the point of 1 billion. Now, what is the concept of the Internet of Things? The Internet of Things concept is like individually based explained. ITU proposed this definition to be the Internet of Things is a system of interrelated computing devices. Could be mechanical or digital machines, could be objects, animals, or even people that are provided with unique identification numbers and the ability to transmit data over a network without requiring human to human or human to computer interaction. So this is the definition that ITU gave about Internet of Things. Like I said earlier, the definition is not generally accepted. It's just a recommendation by the ITU, which means you can have your own definition regarding the Internet of Things. So what is your definition about, what is your definition? What is your own definition of Internet of Things? I would like to know in the comment section. Thank you. Now, the influence. Before now, you must definitely go to see a doctor. And the doctor will use one of these, maybe his hand or one of these devices to check your blood pressure or check your heartbeat and record it somewhere. So you must have to see someone who will be able to do this for you. But nowadays you don't. You must not see anyone to examine your heart pressure or to examine your heartbeat or your blood pressure. So you can use a smart device just like a smartwatch. Just place it on your body anywhere you are, and you begin to have a record of your heartbeat or your blood pressure. So now the access to internet has completely influenced the way we live, and it is not only in smart application, in smart watch or wearable devices, but it's now all over everywhere. So even we have smart applications at home, we have smart vehicles, we have smart devices in the industry. But anywhere you go, you see smart devices. This has also shown the fact that the internet has improved the communication systems and the use of Internet of Things. You see the picture at the left-hand side shows people in a concert in 2005. And if you look at them, you see you have just a few number of people using their phones to video or participate in the program. But that picture on the right hand side for 2013, see a lot of people having phones here and there, some having iPad and so on to cover the activity, and they use it to interact with friends at home or different locations. So this has increased or influenced internet communication and resulting to Internet of Things. Let's look at one of the applications. The application of Internet of Things is numerous. Now, if you look at this picture is looking at grabbing object grasping optimization, where you can use some EMG devices applied to a protected hand, and that hand will be able to optimize the object that it is touching. This can also allow the robot or the amputee to recognize the object he or she is having on his hand. This is a general one. A lot of people know, and if you don't know, you might have heard about smart homes, where you have virtually everything in your home, or the devices in your home interconnected and linked up to the internet. So with that, you'll be able to control all the devices and applications at home from wherever you are. So this is now impossible because you have a good number of storage in our applications. We have a good number of internet speed. We can be able to link up a lot of devices together and also manage the devices over the internet. Now let's look at the key technology. In this area, we try to group this technology into 5 layers. So the first one is the business layer, where you design the business model and also look at the system management. And the second one is application layer, where you look at the graphic data representation and the smart application. The third one is the middleware layer. It could be termed as decision unit, where the data is analyzed and the decision is taken based on the outcome of the analyzed data. So in a short form, that could be termed as the information processing. We have the third one, which is the network layer. The network layer is talking and looking at the network technologies and the data transmission. Then the final one is the perception layer, which is the physical object and sensors and also the actuators, as the actuators as it relates to robotics and other mechanical devices, and that can be termed as a data gathering. Apart from these 5 layers, we can also group these into 3 layers. The 3 layers include the perception, the network, and the application. These are the 3 layers. So what are the functions? The function of the perception is for the device to sense the environment and interact with the things within the environment. So if you have a device that can take temperature within the environment and report the temperature in your room, and with that temperature in your room, you'll be able to regulate the temperature in that room wherever you are. This is the function of the sensing part of that smart home. We have popular protocols for embedded systems. We have modules such as the GPS for localization. We have a module like the RFID for identification. Also have modules like motion, gaze, and also voice interfaces that can give us information about motion, give us information about gaze, and also about people's voice. And another one could be like the temperature sensor, which we mentioned before. We can also have the pressure sensor, a lot of other protocols that we can use under this perception layer. The next one is the network layer. The network layer is looking at the communication principle. What kind of principle are you going to use to communicate this sense information to another device that will interpret it? So you need to know the kind of network communication or the communication that can exist between the two devices. Like we mentioned earlier, you can get the temperature of a room and send that temperature across to someone's smartwatch or someone's computer or someone's phone. So for that information to get to that person's phone, it must have to go through a protocol. One of these protocols could be the Wi-Fi, could be the Bluetooth, could be ZigBee, and so on and so forth. These are available protocols that are that the Internet of Things can utilize for communication. And the third one is the application. So the application is generally looking at the decision making and the flow of how the data is adapted. So the protocol includes the HTTP for web interfacing and also cloud platform for storage and computing. So in a nutshell, we need a sensor which will be under the perception layer. Also, we need controller which will be under the network layer, and we need the application which will be looking at the internet. What is the challenge of the Internet of Things? Now we have devices, we have things, we have nodes. They could be called devices, they could be called things, they could be called nodes. We have them linked up together through the internet. What are the major challenges we are going to face? There are a lot of challenges we'll be facing. Let's just talk about these few. One is the power. We need power. So when you have a lot of things linked up together, you need to um, uh, provide power for those things. So it consumes a lot of energy. That's number one. Even if you begin to talk about minimizing, because you won't be putting all the things on the socket. Some of them could be mobile devices, so they will need like battery for to provide power to them. And you begin to think about how often do you need to charge this battery. How convenient will it be for you to charge your battery? Imagine having all the things, yeah, like the smart systems at your home connected to your phone, and you begin to receive information about temperature, you begin to receive information about the heating, you begin to receive information about the fridge, you begin to receive information about the television, about the lightning, everything in that smart home. So you imagine that it's going to run your battery quicker than your battery should have been run down. So these are some of the challenges. We also have other challenges like the storage of information and the information management, because you now begin to have a lot of data here and there, but we just summarize them to be at this level. Now, let's look at the big data and also the cloud computing and how they are related to the Internet of Things. We know that the internet has made it possible for a lot of people to have access to data here and there. People go to the streets, they take pictures, they send it to someone. People go to a concert, they make videos. Everyone is producing data every second. So because of this, you have a lot of data all over the internet. A lot big data is being generated. So this big data that is being generated need to be supported. And the best way to support them, to be able to have access to them, is to have a central place like a cloud where everyone can have access whenever the person wants to have access. It can be said that cloud computing supports availability to an extent, because if you put it in a private systems, the chances that it will not be available is higher in putting it in a private system than when putting the data in a private system than when you have the data in a cloud computing environment. Now, what is cloud computing? What's the concept of the cloud computing? What does it provide? We believe that cloud computing can provide flexibility and also reduction in the cost of computing. Because you have a central place, you can just pay for a space and then, save your data or store your data there. So you're not afraid of losing your data easily, because most of these cloud computing, they have backups. And again, you're not afraid of, having a kind of unavailability of your data, because there is always power supply, and the battery, the data are almost at all point protected and properly managed. So another thing is that you won't be concerned about getting the IT resources that is required for you to set up your storage area and so on and so forth. Now, let's look at the key technology for cloud computing. The key could be grouped into three. The first one is software as service, the second one is platform as service, and the third one, excuse me, is infrastructure as a service. The first one is the software as a service is looking at providing application-based services, such as the Google app or the Microsoft. This is talking about providing software services. We also have the platform as a service, which is looking at providing essential services for platforms or that is required for specific applications. And in that case, you can be talking about the IBM IT factories or the Google App Engine. Then the third one is the infrastructure as a service, which is looking at renting out an infrastructure which is capable of computing and also for storage. We can talk about the Sun Grid and IBM Blue Cloud and so on and so forth. Now, let's look at big data. Big data. Big data is about data becoming big, in quote. Becoming big in the sense that data are now being generated. A lot of data are now being generated every second. And as people get access to the internet, they produce a lot of data. So you have a lot of data everywhere. So the problem now becomes, how do you manage this data? How do you process the data? Because when you have volumes of data to process, then you begin to get worried of how you get to process this data. So big data is also looking at the whole population instead of just sampling some areas of data, and is efficient instead of saying that it has a single accuracy. So it's generally efficient, but not not narrowed down to a specific or a single sample. So that's the big data. And the third one is a correlation instead of causality. The big data, as we said before, the concept is having very large volume of data and the ability to process this data and get reasonable information from this data. Let's look at still on big data. What are the advantages of this big data? We have big data provider, distributed storage and processing. So you have like storage in some distributed places. It makes it possible also have resource allocation, where resources can be allocated to take care of certain data at a particular time. Yeah, so in summary, that's what we have discussed today. As shown in this slide, we have looked at the introduction about the Internet of Things and the development of the Internet of Things. We also looked at the key layers and technology for the Internet of Things. We first of all looked at it as a 5-layer, and thereafter we looked at it as a 3-layer, looking at the perception, the network, and the application layer. We also talked about the sensoring part, the communication part, and the output part, looking about the protocols, what kind of protocols are involved, what kind of communication are involved, what kind of data processing are involved. So we looked at how all this could be managed. That's it, guys. Thank you so much for listening. Another section we'll be looking at we'll be looking at some sensors, and we'll be also talking about things about the Internet of Things. Thank you so much. Bye, guys.